Hello everyone, so for this video I'm going to be going over chapter 2, which is going to be covering linear equations and their different applications. So let's go ahead and get started with lesson 2.1. And for this lesson I'm basically just going to introduce you to linear equations, and we're going to start by describing what is the definition of an actual linear equation. Okay, so a linear equation, let's see here. Okay. A linear equation in one variable. So here we're only going to be talking about linear equations with one variable. Later on the course, we're going to be learning about linear equations that are going to have more than one variable in them. Is one equation that can be written in the form ax plus b equals 0. Okay? And this is where a and b are real numbers. And a cannot be equal to 0. Okay, so you're probably thinking, well, I see more than one variable here because we have a and b. Well, actually, a and b are just representing the numbers of an equation, right? So we're always going to have a number in front of x and then a number that's going to be being added or subtracted from x, right? So a and b will always be numbers that we're going to know. Right, we're going to know their values. The only variable that it's going to be existent on the exercises and examples of linear equations is going to be x. Okay, but a and b will always be just numbers, right? Just numerical values that are going to be part of the equation. Now notice how it says that a cannot be equal to 0. That means that we're always going to have an x value. If a was 0, then it would be like 0 times x. That means that we would not have an x value. So a cannot be equal to 0. Okay. So that is the definition. Now, something else that we know about linear equations is that the higher exponent of x is 1. Okay, so for linear equations, we're never going to have x with an exponent that it's not 1, or with an exponent, right? Remember, whenever 1 is the exponent, it's invisible, so we don't really see it. So we're never going to have x to the second power, x to the third power if we are talking about linear equations, okay? So that's the definition of a linear equation, and, the way that we can actually, identify this equation as linear is by noticing that x has an exponent of 1. Now again, later on you're going to be learning about linear equations that are going to have more than one variable. We're usually going to be reading them with y and x, right? And we're going to notice that y will also have exponent 1. So for linear equations, we cannot have any exponent that it's not a 1. And here, let me fix this. I was supposed to put highest exponent, not higher. I don't know, I put higher. That should be highest. I have to take the eraser here. Okay. So, the highest. There. Cool. Okie doke. So let's go ahead and get to the properties for equations, right? So something that we can always think about on an equation is that it's like a balance, right? You have these two items and they have to always be balanced. So an equation always, if you notice, it's composed of two sides. We have our equal sign. We have our equal sign right here in the middle. And then we have two sides of the equation. Well, what we always want for this equation is to be balanced, right? If we are taking something off from one side that wasn't there before, then we have to take it off on the other side as well. So whatever actions that are new, that are not part of the original equation, is being done to one side, they also need to be done on the other side. So let's just go ahead and say that an equation, it's like a balance, right? Or let's say an equation always needs to be balanced. Okay, so the reason why I'm saying this is just for you to understand where is the next properties are gonna come from, and again, it's because of that. What I'm saying, it's we have that equal sign, which means that both sides must be equivalent. So whatever you're taking off from one side, you have to take it off from the other side. Or if you're putting something new on one side of the equation, you also have to put it on the other side in order for the equation to be balanced. Okay, or for the original equation to be balanced. So again, that it's gonna bring us to the properties of equality. So for properties of equality, we're gonna let A, B, and C be expressions representing real numbers. Okay. So again, A, B, and C, they're just going to represent numbers. For the addition property of equality, we're gonna say that if A equals B, then A plus C equals B plus C. Notice here how I'm originally only had A equals B, right? This was my original equation. A equals B. There was only A on the left side of the equal sign and B on the right side. Now notice what happened. I added the value C on the left side, so that means I also had to add it on the right side. Okay, so that is the addition property of equality. Whatever you add that wasn't there before, right? Whatever you add on one side of the equation also needs to be added on the other side. Okay, so again, always has to be balanced. Subtraction property of equality, it's going to be pretty much the same concept. If A equals B, then A minus C equals B minus C. So again, we're noticing that we have the original equation A equals B. However, now here, instead of adding C, we're subtracting it, right? Because again, this is a subtraction property of equality. Whatever we're subtracting on the left side that wasn't there before, it was not subtracting before, we also have to put it on the right side. Multiplication property of equality, same thing, right? It's same concept. If A equals B, then A times C equals B times C. We still have the same original equation, A equals B. However, now C, it's multiplying. It was not there before. It wasn't there originally. So because we multiplied the left side by C, then the right side also needs to be multiplied by C. Again, it has to be balanced as it was originally. This is a multiplication. That means that if we multiply on one side, we multiply on the other side. And last but not least, we have the division property of equality, and that one says that if A equals B, then A divided by C equals B divided by C. Okay, so it's the same rule, right? Now with division, instead of addition, subtraction, or multiplication, we are dividing by the value C on the left, so that means that on the right we also need to divide by C. Okay, so basically, for all four basic operations of math, adding, subtracting, multiplying, and dividing, we apply the property of equality, right? If we do something on one side, we have to do it on the other side. Usually what I tell students is that let's think about when girls do their eyebrows. if they do something, if they add, a little bit of makeup on one eyebrow, right? They're actually going to do it on the other eyebrow as well. So then they will look similar, right? So this is the same concept. Let's think about, the left side of the equation being the left eyebrow. Whatever you're adding, subtracting, dividing, multiply, you also wanted to do it to the right eyebrow, right? So they can look good. We girls usually tend to do the exact same thing on both eyebrows, right? So they can look even. It'll be really weird if one eyebrow had more makeup than the other one, right? So you can think about it that way. Just remember, if I do something on one side that wasn't there before, I have to do it on the other side of the equation as well. Now, so there's this now working with equations, right? And what do they usually ask us on the exercises that we're going to be looking at? So when we are being asked to solve for an equation, we're actually being asked to find the value of the variable that makes the statement true. So again, we want to find the value of the variable that makes the statement true. That means that the actual equal sign is going to hold. For instance, if we have, 2x equals 4, right? Then probably x is going to have to be 2 because that'll be 2 times 2. So it's just, and that's going to give you 2 times 2 equals 4. So then both sides will be the same. So again, right now I'm going to be explaining some examples. Right now I'm just kind of like talking about what this actually means, but you kind of want to make sure that both sides of the equation are going to hold and they are equal to each other. If we always, or if at one point we end up with one side of the equation not being equal to the other side, then there's a problem with our solution, and we're going to have to go back and check what is it that we did wrong, right? So now, how do we find the value of the variable, right? So what is it that we need to do in an equation, right, in order to solve it? Well, to find the value of the variable, we're actually going to have to isolate the variable. And to isolate a variable, it means to leave the variable by itself. So that means that we want to leave the variable by itself on one side of the equation. You're going to see some examples later on where we have variables on the left and the right side of the equation. What we want to do is get all of them together only in one side. And we do this by applying the properties of equality, either addition, subtraction, multiplication, or division, which is the ones that we saw before. It's usually going to be either addition or subtraction, not multiplication or division. Okay, so let's go over some examples on this. So let's begin with example A, and let's say that this is B minus 8 equals 5, and we want to solve for B. Okay. Now usually what I do is I draw a line where my equal sign is. And then I'm thinking, okay, B wants to be by itself. That's the variable that we want to isolate, right? It wants to be by itself. Let's say this is a party. There's room 1 and there's room 2. What we need to do is we need to get everything that it's not B from room 1 and move it to room 2. The way that we move it, it's by applying the properties of equalities, right? Now, how do we know what property of equality do we need to use? Well, we're going to look at the numbers or the values that are on the same side of B. In this case, I'm noticing that I have the value of negative 8, right? I have negative 8 right here. So negative 8 is bothering B. We need to get rid of it. And the way that we get rid of it is by doing the opposite of what it's doing to B. I see that 8 is subtracting. So what I'm going to do is I'm going to add it instead. So I'm going to go ahead and do plus 8. Now, I did not have plus 8 on the left side. This is something that I just added, right? Something new that wasn't there. So because I'm the one who's putting this positive 8, let's say randomly, I know that it's not randomly because I'm just doing the opposite of negative 8, but because that wasn't there before, I have to do it on the other side, right? And that's what I mean by moving negative 8 from room 1 to room 2. We move it by doing the opposite, okay? So now from here, negative 8 will cancel out. And now we have b, right, equals 5 plus 8. Now 5 plus 8 is going to give me 13. Now b is by itself. There is no value that it's being adding. There is no value that it's subtracting. There is no value that it's dividing or multiplying. Actually, for multiplying, we can say that there's an invisible one in front of the b, but we don't really care about that invisible one. It doesn't really affect b. So we say that b has been isolated, so we can say that the value of b equals 13. And now we can double check that solution. And the way that we double check it is we can go ahead and replace this 13 into the original equation. So we had b minus 8 equals 5. We can just go ahead and plug in 13 in b. So 13 minus 8 equals 5. 13 minus 8 is 5. So notice how both sides of the equation are the same. That means that it's true. The equation holds, and b equals 13 makes the statement true. So b equals 13 will be the solution. Now, I also wanted to show you some different ways of solving equations. Notice how I went like vertically. I kind of did, like the positive 8, I added it vertically to 5 and then to the negative 8. So that means that I just put it below the equation. That's the way that I usually do it, but I'm going to show you how to do it horizontally. Some students like that better. I think the textbook does show you how to do it horizontally instead of vertically. It's the same steps, so it's still, you still have to, add 8, so do the opposite of the number, and then you end up with b equals 13. But instead of having, like b minus 8 equals 5 and then adding 8 under the equation, they usually write it like this. So they go like b minus 8, and then they put plus 8 on the side, and then equals 5 plus 8. Okay. So at the end, we're noticing that negative 8 and positive 8 become 0, right? So they cancel each other. So then at the end, b equals 5 plus 8, which is 13. Notice it's the same answer, right? Same concept. We're applying the properties of equality. We're adding a to cancel it or to get rid of it from on the left side. However, instead of being vertically like the way that I did it first, they do it horizontally as well. That is up to you. I don't mind if you do it either way. Whatever it's easier for you to understand, I'm cool with that. Okay, so just wanted to give you a heads up because I think the textbook does show the horizontal way. So just for you to not get confused and think, oh, should I do it, like the way that Miss Quintero did it, or should I do it the way that the textbook is? No, it doesn't matter as long as you know how to cancel those values and isolate the variable. Okay. So I'm gonna go ahead and erase this. And let's go over another example, okay? So, this is example B. So for B, we have negative 9W equals 36. Okay. So again, I'm going to go ahead and draw, let's say I'm going to draw my wall here where the equal sign is. And the reason why I draw the line, you're probably thinking, why does she even draw the line? Well, it's just for me visually to be able to differentiate the left side of the equation from the right side. And as we keep going along, right, keep in mind that there's the left and there's the right side. For some students, it's just a little bit harder to understand that there's a left and right whenever they keep working on their equations, right? If we're adding or subtracting, the more steps that we do, we can get to the point where we kind of get confused and cannot differentiate from both sides of the equation. So that's the reason why I'm just drawing the line, just so we can tell the left from the right side. So here we have negative 9W equals 36. Now here I have W, which is the variable that I want to isolate. So W is not happy right now. It's, it wants to be left alone, but we have that negative 9 multiplying it. How do I know that negative 9 it's multiplying it? There's no symbol, or there's no like operational sign between 9 and W. So there's no plus, there's no minus in between. Remember that when we have a number and a variable together, right, with no symbol in between, that means that they're multiplying. And this negative belongs to the 9. So it's a negative 9. A lot of students, what they do is they see this negative and they automatically think, oh, this is subtracting 9, right? So it's 9 is being subtracted from W. But let's remember that we're looking in between the number and the variable. Here, there's no minus in between. That means they're multiplying, and this negative belongs to 9, okay? So, again, that negative belongs to the 9. So, negative 9, it's multiplying W. Now, it's multiplying, right? So what we have to do is do the opposite from multiplication. Now we know that the opposite of multiplying is dividing, right? So to get rid of this 9, what we're going to have to do is divide by negative 9, okay? Notice how I'm taking that negative with me as well, okay? So if I'm multiplying by a negative and I want to get rid of it, I also divide by a negative, okay? Now, since I'm doing that wasn't there before on the left side, I'm also going to do it on the right side. So negative 9 and negative 9, let's say they cancel out. They actually become negative 9 divided by negative 9 becomes 1. So this becomes 1W at the end. But remember, 1 becomes invisible. So if I have 1 in front of W, it becomes invisible. So I can just say, okay, I'm going to be canceling negative 9 and negative 9. So the 1 becomes invisible. Okay. And then 36 divided by negative 9 will be 4 negative. Why is it negative? Because I have a positive divided by a negative, which is a negative, right? That's what we saw last week. When we have two numbers that are opposite signs and they're being divided, the answer will be negative, okay? So if we do negative 9, just to double check, times negative 4, negative times negative, it's positive. 9 times 4 is 36. So yes, this is a true statement, okay? Let's go ahead and try another one. So for this one, we're actually gonna be, it's gonna be a little bit longer. We have 20 equals 13 plus 1 over 6n, okay? So this problem is gonna be a little bit longer, as I was saying, because I'm noticing my variable, it's on the right side on this one, but I'm noticing that I have two different values on the same side of the variable. I have the 13 and I have the 1 over 6, okay? Whereas before for A and B, I only had one value, one number that was on the same side of the variable, right? So the more items that I have on the same side of the variable, the more steps that it's going to take me to solve the equation, okay? So here I need to get rid not only of the 13, but also of the 1 over 6, right? So that's 2 steps, because I have two values, that's 2 steps that I'm going to have to do in order to isolate my variable. Now, I also want to point out that how the variable now it's on the right side. Before we had it on the left side. Now, because we usually read from left to right, it's easier for us to grasp the concept of the variable being on the left. However, if the variable is on the right, that's totally fine. The same concept applies. The property of equalities are not going to change. The only different thing is that now our variable is going to have to be on the right side, right? Maybe at the end you just want to rewrite the equation so you can see it on the left side. But for now, let's just get used to the idea that variables are also, it's also okay to have them on the right side of the equation, okay? So let's go ahead and get started. So we have two values. We have, as I was saying, the positive 13, and we have the 1 over 6. There's always an easier value to get rid of first, and that is the value that does not have the variable. And let me make a note on that. It's always easier to get rid of the number. I'm just going to put number with no variable first. So basically what we're saying here, it's like 13 is a friend and 1 over 6 it's a spouse, right? It's always easier to get rid of a friend than getting rid of a spouse, right? I know you're probably thinking, well, there are some friends who are way too harder to get rid of them than a spouse, right? But let's just think about it. You know, like let's say in the legal way, it's easier to get rid of a friend than a spouse. Let's say 1 over 6 is the spouse of n, right? They're multiplying, and then 13 is just the friend, right? So it's going to be easier to get rid of the 13 first. Now this 13 is positive. We don't see the sign, but it's a positive, and then it's adding, right, to the term that has the n. So that means that to get rid of the 13, we're going to have to do the opposite, which is subtraction. This 13 again, it's positive, so I'm going to move it as a negative. And because it wasn't there before, negative 13 was not on the right side, then I also have to put that on the left side. Remember the eyebrows. We just subtracted something from the right eyebrow. We have to do it on the left eyebrow as well. So 13 and 13 are going to cancel out. So I have 20 minus 13, which is going to give me 7. So I'm going to get 7 on the left side, and then I still have the 1 over 6n. I don't know what happened there. Let me rewrite that. Minus 13. There. Okay. So I have 1 over 6n, right? N is still not by itself. It's still not happy. We still have that 1 over 6. And remember, this 1 over 6 is multiplying by n, right? Now, there's an easier way of getting rid of fractions that are multiplying by a variable. And that's by multiplying for the reciprocal of that fraction. So if I have 1 over 6 times n, then I can get rid of 1 over 6 by multiplying times 6 over 1. Okay, this is the reciprocal. The reason why we do the reciprocal, right, which is 6 over 1, it's because n it's multiplying by 1, right? So we're going to be dividing by 1 now. N is being divided by 6, which is the one on the bottom of the fraction. So now we're going to multiply by 6. So we're still doing the opposite. So 1 it's canceling 1, and 6 cancels 6. Now because 6 over 1 was not there before, I also have to multiply on the left side. So I have 6 over 1 times 7. Okay. Now this 7, I'm going to go ahead and include a 1 on the bottom. Remember that fractions multiply across. So 6 times 7 is 42. And then 1 times 1 is 1. So 42 over 1 equals n. So that means that 42 equals n. And that will be my solution. Okay? So again, always ask yourself, what are the numbers doing to the variable? And are they positive and negative? So you always have to ask yourself for what are they doing with the variable and what sign are they, right? Here 13, we noticed it was adding and it was positive, so we had to subtract that 13. 1 over 6, it was, multiplying by n. 1 multiplying, 6 dividing, but let's say the fraction 1 over 6 was multiplying, so we apply the reciprocal. Okay, so let's go ahead and make a note on that. So to cancel fractions, and again, fractions that are only multiplying, okay? We multiply by the reciprocal. Sometimes you're going to see fractions that are adding or subtracting. Those ones we cannot do the reciprocal. This is only for fractions that are multiplying the variable, okay? Cool. So let's go ahead and see a couple more examples on equations. Now, the following equations are going to require more steps. They're going to be a little bit longer, and you're going to see that it's probably not even going to take us 3 steps. It's probably going to take us longer than that. But remember, the objective is always to get the variable by itself. And that's one of the things that students need to remember. When working with equations, we always need them to we always need to remember that our goal is to get the variable alone, right, by itself in one side of the equation. So, let's see. So for this example, we have 5. So again, let's say we want to solve this one, right? So 5 and then parentheses 3 minus 2a, and then plus 7a minus 2 equals 2 parentheses 9 minus 2a, and then plus 15. Now let's remember that when we everything that we're doing, everything that I'm about to do, I have already shown it to you either last week or I just showed it to you on the previous examples and with the properties, right? Nothing new is gonna be coming out of on this problem. It's just a mixture of what we have been learning since last week. Okay, so notice how we have 5 parentheses 3 minus 2a. That means there's going to be some sort of distribution right here, the distributive property applying. And then we have 2 parentheses 9 minus 2a, again, another part of a distributive property. Now, what I'm going to do first is the same thing that I did before. I'm going to draw a line where the equal sign is. There, okay. So, let's see, if I distribute 5, remember 5 will multiply 3 and it'll multiply the negative 2a. So it's multiplying. So 5 times 3, it's 15. And then 5 times negative 2a, it's negative 10a. And then I'm going to bring down the 7a minus 2 equals, and then same thing with the 2, right? I'm going to go ahead and distribute it. I want to get rid of those parentheses. 2 times 9 is 18, minus 2 times 2a is 4a, and then plus 15. So here what we did is we applied the distributive property. Cool. So now next thing that we can do is let's go ahead and simplify each side of the equation, right? Notice we have like 4 terms on the left and then 3 terms on the right, but those can be simplified because I have like terms. Remember, like terms are those that have the same variable with the same exponent. For instance, here I have 15 and negative 2. Those are numbers, so they can be combined. And then I have negative 10a and positive 7a, okay? So if I combine them, 15, if I take away 2, that will give me positive 13. And then negative 10a plus 7a will be negative 3a. Okay, so 10 is negative and 7 is positive. I find the difference, which is 3. And then 10 is greater, which is negative, so it's going to be a negative 3. On the right side, I'm also seeing that I have 18 and 15, right? Those are the only like terms, so I would, and then negative 4a is just going to be negative 4a. There's nothing that we can combine it with. So this will become negative 4a, and then 18 plus 15 is going to give me 33. So what we did on that step is we simplified. Okay. We simplified by combining the like terms. Now, from here, what we want to do, notice how we have negative 3a on the left side and negative 4a on the right side, okay? Remember what I said, to isolate a variable, it means to get every single term with the variable in one side of the equation. That means that either I have to move the negative 4a to the left, or I have to move the negative 3a to the right. Okay, so what I'm going to do is I'm going to get the variables on the same side. So get variables on same side. And to do that, I'm going to move the variable that has the lowest coefficient. So remember, coefficient is the numbers in front of the variable, right? So here in this case, I have a negative 3 on the left and a negative 4 on the right. Negative 4, it's lower than negative 3, so I'm going to be moving the negative 4a to the left. How do I move it? I take the opposite. So if this is a negative 4, I'm going to go ahead and add 4a on both sides. Remember, if we do it on one side, we do it on the other side as well. Remember the eyebrows. So 4a and 4a cancel, become 0. So now I have negative 3a plus 4a, which is 1a, and then plus 13 equals 33. Okay. Now I want to get the a by itself, but I still have that 13. All right. So now the last step is to isolate the variable. So what do I do to isolate a? I'm going to go ahead and subtract the 13 because that 13 is adding, right? So I'm going to go ahead and subtract it on both sides. So now a equals 33 minus 13, which is 20. Okay. And we are done. Okay. Cool. So that's it. So that will be our solution. A equals 20. A has been isolated, and we have found its value. What we can do also is we can go ahead and plug in 20 into A just to confirm that the statement is true. I'm not going to go ahead and do that step. I'm just going to go ahead and jump to the next example. But this is, as you can notice, this equation has required for us to do more than one or two steps, right? Like in the previous one. So in the previous problems here, we had to do like several steps, maybe like about 4 or 5 steps, right? So just keep in mind that the goal is always, always, always to get the variable isolated. Once the variable has been isolated, we have found the solution of the equation. Okay. So I'm gonna go ahead and try another example before I go to the next concept of the lesson. So I'm gonna go ahead and subtract this, not subtract, I'm talking like in math terms now. I'm gonna go ahead and delete this, okay? And I'm gonna get rid of this as well. For some reason I thought that space would have been enough for the two problems, but I guess it wasn't. I guess I've been writing too big on the on the on the screen. But let's go ahead and work on the next problem. So this one, it's 1 over 5 y plus 1 equals 3 over 10 y plus 1 over 4. Okay. Now the reason why I chose this example is because it's full of fractions. And I know, it looks really complicated. It looks like a lot is going on. So that's the reason why I want to show you how to work with this type of equations. If you can work with this equation right here, you're going to be able to manage, all the other problems on the chapter. So what I'm about to show you on how to work on this on this equation, it's basically something that we have seen before as well. When I showed you about adding fractions or subtracting fractions, right? So the idea for this problem is first to find the LCD, remember the least common denominator of all fractions in the equation. So we can see that for the denominators we have a 5, we have a 10, and we have a 4. Now this 1, I'm just going to go ahead and put a 1 over 1 just to say that a 1 is also a denominator. But 5, 10, and 4 are the specific ones that are actually going to help us, find that LCD. 1, it's not really going to change the values of anything else, right? So we need to find the LCD. Remember that to find the LCD, we're going to list down the times table of each of the denominators. So for 5, we have 5, 10, 15, 20, 25, 30, and we can keep going, right? For 10, we have 10, 20, 30, 40, 40, 50, and we can keep going. And then for 4, we have 4, 8, 12, 16, 20, 24, and you can keep going. What we want to do is we want to find what is the lowest value that they all have, that they all share, right? So from here I can see that 5 has 20, 10 has 20, and 4 has 20. So that means that my LCD equals 20. Okay? So that is the first step. Second step is to multiply both sides of equation by the LCD. What that means is that we're going to multiply every single term. So every term, it's going to be multiplied by 20. So I'm going to have 20 times 1 over 5y, and then plus, and then 20 times 1 equals, and then again 20 times 3 over 10, and then plus 20 times 1 over 4, right? So the LCD 20, it's being multiplied by every single term. Okay? And now what we can do is we can reduce, right, all of these fractions as we're multiplying by 20. What do I mean by that? Well, 20 times 1 over 5, right? 20 and 5 can be reduced with the number 5. So 20 becomes 4 and 5 becomes 1. Now 20 times 1, there's nothing that we can really do to cancel. We just multiply 20 and 1. 20 times 3 over 10, 20 and 10 can be reduced. So 20 becomes 2 and 10 becomes 1. And then 20 and 4 can also be reduced when 20 becomes 5 and 4 becomes 1. So we're kind of dividing the 20 by the denominators. Okay? So 4 times 1y will become 4y plus 20 times 1, which is 20, equals 2 times 3, which is 6, plus 5 times 1, which is 5. And this one is supposed to have a y, so this should be 6y. Okay? Notice how I ended up with 1s on the bottom. I'm not even bothering to putting over 1 because I know that any value divided by 1 is just going to stay the same. So these 1s on the bottom, let's just say that they become invisible. Okay? So I have 4y plus 20 equals 6y plus 5. Now from here, I can go ahead and solve my my equation. Okay? So I'm going to go ahead and draw my line. Notice how I have y's on both sides of the equation. I don't want to have y's on both sides, so I'm going to move the y with the lowest number in front of it, which is a 4. So I'm going to go ahead and subtract 4y on both sides. Remember the properties of equality. Y and y, 4y and 4y cancel. Now I have 20 equals 6y minus 4y, which is 2y, and then I bring down the 5. Okay? Now, y is still not by itself. I need to get rid of the 2 and the 5. Remember what I said, that it's easier to get rid of the value that does not have the variable first, right? So first I want to get rid of that positive 5. So this is a positive 5. I'm going to move it as a negative. So 5 and negative 5 cancel. So I end up with 2y on the right side, and then 20 minus 5, it's 15 on the right, on the left. And y is still not by itself. 2 is still multiplying y, so what I'm going to do is I'm going to divide by 2. 2 is multiplying because there's no plus or minus in between, so I'm going to go ahead and divide by 2. Okay, so 2 divided by 2 becomes 1, so they kind of like cancel each other. So y equals 15 over 2, which is 7.5. And y has been isolated, so that is my solution. Okay. This was a little bit longer because we want to get rid of those fractions, right? Remember, the way of getting rid of them is by finding the LCD of the denominators, right? Of all the fractions, and then we multiply by that LCD. If you find the right LCD, notice how at one point the fractions just end up disappearing as we are reducing. Okay? Cool. So let's talk about the different type of solutions in a linear equation. So we can either have one solution, we can have no solutions, and we can have infinite number of solutions. Now, how can we tell, when do we have no solution, or when do we have infinite, or when do we have one solution? Well, for one solution, we're usually going to have a solution that it's going to be just a real number. And what I mean by that is that our solution is just going to be a number. For instance, here, y equals 7.5. That's a one solution. It's a real number, right? The way that we got a equals 20 on the previous problem, that is one solution. In 20, it's a real number. So those are examples of equations that have one solution. Now, we also will find equations that have no solution. And how can we tell when we have no solution? Well, the first thing is that the variable, you're going to notice that the variable will drop out. And what that means is that it's going to cancel. So we're going to end up with a point where there's no variable. We're not going to have an x. We're not going to have m, a. We're not going to have a letter in the equation. It's just going to be numbers. And the second thing that we're going to notice whenever we have no solutions is that we're going to end up with a false statement. So after we have canceled the variable, right, after we have noticed that the variable is dropping out, we're going to notice that the numbers or the values that we have on both sides of equations don't match. So for instance, we're going to have at the end 2 equals 15. Something like this. Let's say you end up with a 2 on the left and a 15 on the right after canceling the variable, right? In that case, this is not a true statement because the number 2 will never be equal to the number 15. So that is an example of when we have no solution, okay? Then we have some examples or some exercises where the answer will be infinite number of solutions. And then how can we tell that we have an infinite number of solutions? Well, First of all, the variable will also drop out, just like in the no solution. So that means that it'll cancel. However, instead of having a false statement after the variable cancels, we're going to have a true statement. And what that means is that we're going to have the same value on both sides of the equation. So 5 equals 5. This is true. The number 5 equals to the number 5, right? So whenever we encounter an example where the variable cancels out and we end up with a true statement, that will be an infinite number of solutions. That means that it doesn't matter what your variable is, the equation will always be true. Okay? You can put whatever value you want for the equation, for the variable, and the equation will always be true. Okay, so there's an infinite number of solutions. So let's look at a couple of examples on this. Let's say the first one, for the first one we have, let's say, let me change to red. So example A, let's say it says 6 plus 5x minus 4 equals 3x plus 2 plus 2x, right? So now what I want to do, I draw my line, and I want to simplify, right? So I can see that 6 and negative 4 are like terms on the left side, which is going to give me 5x plus 2. The 6 take away 4, it's 2. And then on the right side, I have 3x and 2x that can be combined. So that will be 5x plus 2. Okay. Now, I'm going to go ahead and remember we want both variables to be on the same side. So I'm going to move one of the 5x's to the other side. So I'm going to go ahead and subtract the one on the right to the left. So 5x minus 5x cancels. I end up with 2 on the right. And then notice on the left, I also have 5x minus 5x. So those two cancel as well. So I have 2 equals 2. This right here, it's a true statement. So that means, you know, the variables dropped out, right? They cancel, and we ended up with a true statement. So that means that this has infinite number of solutions. And that's going to be your answer. Infinite number of solutions. Okay? So this is the final answer for this equation. Okay? Let's do another example. And this one is 3x minus 4x plus 9 equals 5 minus x. Same thing, I'm going to draw my line where the equal sign is. And I'm going to go ahead and simplify both sides. So here on the left side, I have 3x minus 4x, which is negative x, and then plus 9 equals 5 minus x, right? On the left side, there's nothing that we can combine, right? So we just rewrite 5 and negative x. Now, I'm going to go ahead and add x so I can have them both on the same side. So this x and this x are going to cancel out. And then I'm also noticing that this x and this x are canceling out as well. So now I have 9 equals 5. Now, 9 equals 5, that it's false. This is not true. So because the variables dropped out, the variables canceled, and I ended up with a false statement, then this is a no solution example. Or this is an example of a no solution answer, okay? Cool, so now let's go to writing equations whenever we have, whenever they give us like an actual sentence, like a English sentence, I'll say, how to write the equation from there. This is related to what I showed you previously on week 1. Remember that I will give you like how to translate from English to math. Basically, we're going to combine that. We're going to write from an English sentence, right? So yeah, just a sentence to the math, right? And create an equation with that. So remember, it's like writing an expression into math, but now with an equal sign, right? Which is what makes the difference between an expression and an equation. Expressions don't have the equal sign, equations do. So, okay, so let's go ahead and get started. So we have 9, it says 9 more than twice a number is between, is 17, or is 17. Thought it said is between. So 9 more than twice a number is 17, okay? So remember I showed you that we are going to break the sentence apart in the sentence in parts, right? So here I can see that 9, well that's just going to be the number 9. More than means addition, so we're going to be adding 9 plus twice a number. Now here's where the variable is going to come in place, because it says a number, that means that we have an unknown value. Twice means 2 times, right? So this is going to be 2 times, let's say, x, number x. And then is. So this is a new part. So is in math is translated as equal. Okay? So the word is in math, it becomes the equal sign, and then 17. Okay? So just to write it down, is in math becomes equal. Okay, so now let's go ahead and just put them, closer to each other. So 9 plus 2x equals 17. If I go ahead and solve for 2x, then, or solve for x, then I subtract 9 on both sides. So I end up with 2x equals 17 minus 9, which is 8. 2 is multiplying the x, so I'm going to go ahead and divide by 2 on both sides. 2 divided by 2 becomes 1, so x equals 8 over 2, which is 4. And that is my solution, okay? Let's go ahead and try one more. So, this is, let's try just one more example. And this one is 3 less than 5 times the number is the same as the number increased by 13. Okay. So, let's see, it says 3 less than. Let's remember that less than means subtracted from, okay? So here we have the number 3, so that means 3, and that it's being subtracted from 5 times a number. So 5 times a number can actually be, translated as 5 times, let's say, number n. A number, that means it's an unknown value, right? So let's say it's n. And then this is 3. So we have 3 subtracted from 5 times n, this is will be the equal sign, the same as, so this is the same equals, the numbers that means n, the number n, increase means plus by 13, so 13. So we will have 3 subtracted from 5 times n. So 5n minus 3 is equals n increased by 13 plus 13. Okay? And then we can go ahead and solve. I put 3x. That should be n. Why did I put 3x? Oh Lord. So this is 5n. So I'm going to move the n with the lowest coefficient. So this n, I'm going to subtract it on both sides. So 5n minus n is 4n minus 3 equals 13. I'm going to go ahead and add 3 on both sides so I can get my n by itself, right? So then I end up with 4n equals 16. 4 is still multiplying n, right? Which is the one that I want to get by itself. So I divide by 4 since it's multiplying. So n equals 4. And I found my solution. Okay? So that is lesson 2.1, guys. I will be uploading more videos for some applications of linear equations and some inequalities that we're going to also be covering for today.